stage 2, and now we have the new team Excelsior. Reviewer, could the team captain introduce your team member, their name and grade, and describe what their favorite topic in physics?
So we are Team Excelsior, and we are from Concordia Middle School. And I am Chen Xiaochen, and this is Zhou Xingyu. This is He Ziwei. This is Chou Jiajun, and this is Li Yining. And we are all first graders for high school. And for interesting physics topics, we find quantum physics to be quite interesting. And we also we like electricity, in the physics of electricity. And also we find force analysis. Yeah, forces.
Okay, very nice. Thank you. Welcome. Now the opponent challenged the reporter for the problem.
I could challenge the reporter problem 7 through a pattern.
Oh, 7. Problem number 7. Ruder canoe. Accept? Okay, so it's good. Very efficient. So now preparation of the reporter 5 minutes. And each thing write down represented name on the blackboard. Number 7. Okay.
And another one is that the tendon close to one of the ends, because I have to make a side will be static. And the other one is the extra force. I have to give the force to the ruler. So this is the main focus on my experiments, because how to control my force is a quite important problem. This is the picture. I will explain for everyone. This is the ruler, and this is another one. I will put my rulers on the table, and I will give the extra force here, and the length of this is 15 centimeters. And when I will use three kinds of different rulers, there are 30 centimeters, 40 centimeters, and 50 centimeters. When I use a 50 one, I use the 50 centimeter ones. The length between the ball and the extra force will become 15 centimeters, and the other one will become 30 centimeters, and the length will be stable. And this will depend on the different rulers I use. And when I press a point, the force will become like this. And when the force of this is bigger than this one and this one, the ball will eject it. This is a problem statement. I put the rulers on here, and I get the force slowly so that the rulers will bend more clearly. And I will put it on the chair. And when it ejects, I will have to measure the length gap it is. This is a phenomenon and related parameters. The dependent variables will become the flight distance of the ball. So the position depressed and the force to apply, and the other one is the quantity. For example, the length and material of the rulers will impact on the result of the experiments. But there is a problem. Is that the position depressed is I can control the position depressed. It's not like this is not another independent variable, because when I put the ball here, how I give the extra force, the ball won't eject it out. So I won't put the first one in my experiments. Oh, another one is that the force to apply will be constant. So this two one will be the independent variable. No, it will be a control variables in my experiment. Okay, and this one is Gauss modulus, because the ruler will have the deflection, so I have to talk about the Gauss modulus. So, and I will ensure that every time the ruler will in this space, so that it won't here to have the unlimited strength. This was the theory. When I press, I give the force to the rulers, the force will totally become the elastic potential energy, and part of elastic potential energy will become the kinetic energy. And this is the energy conversation. Efficiency can be defined as this: the kinetic energy divided by the force I give to the ruler. And this is a theory. Here, the L is the present point I give the force to the ruler. I also use the U to make the kind of the formula investigation. So I will get the velocity there. Okay, this is a theory. ejected appropriately. Here is how I. This is how I know the elastic models of the Young's models of the ruler. I put three. I use some. I measure the gravity of the three tiny things, and this will be 75 kilograms. Okay, I use the kind of ruler to do the experiment. This will be the thing here. So if I measure all the things here, and I don't know the Young's modulus, but I know the deflection, so I can get the Young's modulus in the kind of formula. Yeah, this is how I do the experiment. And this is a result of the experiment. And this is although there might be some invisible error in the invisible things in my experiment, but I'm very glad that the Young's modulus of the three rulers will be in the range of 1 times 10 GPa. And this is a conclusion. And the main point of the conclusion is the ruler, which is longer, will have more obvious deflection. It will bend more. This is the experiment to measure the ruler. The independent variables is the length of rulers. I use 30, 40, and 50 centimeters rulers to do the experiment. And this is the experiment setup. It's as same as the one I talked about in the last experiment. I use a round projectile, and I ensure the diameter of it is 40 millimeters. This is the time. The time will impact on the deflection of the rulers. Due to this formula, I can know the flight distance of the ball. And this is how I conduct the experiment. Okay, I will talk about the time. If the force is applied too briefly, the ruler does not fully deform, meaning x is small, leading to a lower launch velocity.
preparation of the opponent to the reporter.
Okay, thanks for reporting, but since you didn't show pages, so in your experience, does the ping pong ball deform in your situation?
No,
Okay, and how do you apply extra force?
imply extra force. I use a plane to like push the rulers.
So you use a hand to push it.
No, I use a clip to.
A clip to push the ruler. Okay,
Yeah.
got it, thank you. And so how do you, in experiment on the left, different length experiment. So what's the difference between these different length of rulers?
Oh, different?
You have to do an experiment about different lengths of ruler.
Different? Oh,
So what's the different point of these different lengths of rulers? Okay, that's fine. Thank you. And so do you use the same material in your experiments?
same.
Of rulers?
Yes, it's all plastic.
Yes, okay, I got it. And do you consider friction between the ball and the rulers?
Yes, because I draw it on my picture. Here. Oh, here. This one is a friction, and
So that's why the friction.
Yeah.
So I think you could just add a title to show that the friction.
yes, I activate in the
Okay, and do you consider a bending situation of the rulers?
bend.
Bending situation, because you apply the force, the ruler might bend, I guess.
Yes, I consider that.
So you think that the force that the ball is gave by your hands, because you have to try to hand your force by your hands.
Yes, and to the elastic potential force and the part of elastic potential force turn to the kinetic energy.
Oh yeah, I got it. So yeah, maybe kind of agree with you. I think that's my questions for the reporter.
Okay, thank you. Preparation of the opponent, 3 minutes. Opponent takes the floor. Next 4 minutes.
Okay, so now we run on the opponent from Team Berlin, and today I'm going to oppose cover 7 ruler tendons. Two rulers are tightly held against each other. A rough project held is exerted between them close to one of their ends, and when extra force is exerted on the surface of the rulers, the project held is ejected at high speed. And the reporter needs to investigate this effect at the parameters that affect the ejection speed. About the summary of the report, the reporter used some model like graphic to show how the force passes over to a bolt. I think that's a very creative idea to show the process between the ruler tendon and how you use the elastic force to transfer into a kinetic energy and then compare the difference. And also use a Young modulus to describe the potential energy of the ruler, how big it is, and also use some equation to try to measure it, and also flight distance. And about experiment, the reporter used two identical rulers to do experiment, and also do some parameters with some different Young modulus with a different depth of the ruler, and also use a ping pong ball to do the experiment. So, and also the result that shows that the more Young's modulus cause the less velocity of the ball, and also the less length cause the more velocity of the ball, so it becomes where the ball is ejected out faster. For summary of the report, in here the reporter shows a simple physics explanation to show how the ruler actually passes force to the ball, and also can consider the friction. I think is also important, and also I'm clear about it to do about like the beam theory to describe how the bending situation of ruler is. And also, you see that I also have some quantitative theory to describe how big energy is, because I think energy is the most key important in this ruler pattern. So, and about suggestion is that I think the reporter could put less words and just to simplify how the process goes, and to show more video about experiment to put how exactly how fast it is, and also show how the reporter apply the force on the surface of the ruler. So I think it could be better if the reporter could show more video to prove the experiments set up in the report. And also, I think the reporter could compare the different when the reporter do different parameters. So I have with some different results. So I think the reporter could try to compare and also analyze the different energy between these two parameters. And also, I think there is some more very good quantitative explanation. The reporter have drawn some easy graphic to show the rulers and the bolts connection, and also draw some graphic to show how the bolt eject out, and also use some way to measure the Young modulus. And for my focus, the point of the discussion is later discussion. I will try to maybe I also have some misunderstanding, so I will try to figure out the order. So first it's about the mechanics of energy transfer. Because the report have used the kinetic energy and the elastic energy. So I would like to ask how the energy transfer into this system. And for second it's about extra force. And about also something how analysis to talk about the different energies difference. And also I'll talk about binary, the importance of binary here. I would like to ask some question about how we measure the Young modulus here. Because also the moment of inertia of the ruler and some different parameters to experiment to compare to see the difference of those in the reporter. So that's our discussion with the reporter.
Okay, so now you want to move to the discussion with the reporter. Okay.
So can you show me how you measure the page? That's me. Yeah, can you tell me what you were trying to present in this picture?
Oh, the picture is cut by I don't know why it is cut, but here's a ruler, and
So let's try to draw it.
okay.
Yeah, because.
And the ruler will be left like this, and I will measure the length of the deflection of the ruler, and I will know this is a deflection.
So you put a weight at the part of the ruler, so make it dependent to make it deflect down.
Yes.
So the deflection, your definition of deflection is this part.
This.
And tell me what's the deflection with 75 grams here.
Oh, this is the.
Yeah, I mean when you put a 75 grams of weight on here, so how big the deflection is of your rulers. Okay, so you put it in this way. So may I ask you about how you, which position that you apply your force in your experience. Let's draw a graphic. Just you put a lure like this here, and put a bow, and also here. I mean, which part did you apply the force? This part or this part or this part or this part?
Okay. Do you mean that how I know the direction by also?
Yeah, because I think that you put the weight. So can you first tell me which position you apply the force?
Okay. I think I didn't like tell you clearly, but it is like this is different equipment. This is how I measure the gadget, and this one is the one I will.
Yeah, but so you think this is a two direct time experiment?
Yes.
So you just want to show how big the modulus is.
Yeah.
Yeah, but in your theory of energy, you also modulus to calculate out how big the energy is.
Yes.
So can you tell me okay, in this experience, which position do you just don't care about this experience?
I put the ball here and the place I press is.
So do you think the situation that you can use the young modulus is same as this situation because you put a force on the end of the lure, but here you apply the force in the middle part.
Oh, I think in that Gauss model is just a property of the rulers.
What's the part?
It's
Like the depth or something else, like width or some. Yeah.
it's just it depends on what rulers I use because every ruler is different. So I have to know each Gauss model of the different rulers.
So you mean you try to count the different materials like the metal or plastics will have?
No, different than of the plastic ruler.
So can you tell me how do you? Okay, that's fine. I got it. So you use the different plastics. So how about the moment of inertia, the height? How do you measure it? Or do you measure it out?
Yes, I do. This one will have to
Yeah.
look for this one. This one is the moment of inertia. This is the moment of inertia, and I will use this to calculate the I here.
Okay, so can you show me a page that you do the different parameters around the lengths of rulers?
Length of rulers.
Yeah.
This one is this one.
Not this one. Yeah.
Oh,
So what's your independent rule? So you use a different depth of rulers,
yes.
and we have different results.
Different.
With different ejection velocity on the pole, right?
Yes.
Can you tell me why there's a difference between these different depths of rulers?
Different length of ruler.
Why the different depth of ruler will have different ejections?
Oh, this is because this one. It will depend on the Gauss modulus in here, and I know that it is velocity here, so it will impact it.
So okay, so you use Homer equation to measure how big the velocity should be.
Yes, I actually compared those different results.
Yeah. Okay. So and also results just like nearly the velocity of the speed.
No,
Can you
no.
can you tell me why there's a difference between theory?
Oh, because there is a limitation. I don't know why there's when the balls are in a different position. Sometimes I can't every time I do the experiment I will pressure and my ball will put it here. So every time I press it, the ball will eject, but sometimes it put it here, but when I press it won't eject. So I won't calculate this one.
I mean, you have shown data about the different velocity of ejection.
Yes.
I mean, why there's a difference between the theory and your experiments? I mean, maybe there's some energy loss or something else.
Actually, I just used the formula to compare the different one. So I predict that the 30 centimeter one will have higher horizontal velocity than the other one.
Okay, I got it. So I think maybe you could show more graphics about how you put it in place. And but you said that position will be changed in the eject process, the ball's position?
Oh no. Oh no, yeah. The position will be here. Won't change.
So you have to do you consider friction? Or
I know here's some friction, but every time I put the ball here, the friction won't be the independent.
so can I have some more detail, like a real number of how big the friction is? So I think maybe you can prove your assumption more.
Oh.
I guess.
Okay. But the position I put the ball it remains the same, and the extra force I give to the rollers will remain the same. So all the things remain the same. This won't be the independent variables of the experiment.
Okay, got it. So yeah. And for this case, you may ask the mechanism between that you put an extra force and how the force will pass over to your point.
Okay. Here, I give the extra force to the ruler, and the ruler will bend. It means that it has the elastic potential energy. Yeah. And some of the elastic potential energy will be lost because of the damping force, such as friction or something in the rulers. So part of
What's basically the rulers? What can be the damping force?
friction or friction. I think the main reason is friction. And I do the theory investigation to know the percentage that this is the percentage that the force become to the elastic potential energy.
Okay, guys. So can you explain what the equation of this means?
Oh, because this is not a spring, so we can use Hooke's law. So I use this to know the elastic potential energy.
Okay, and what's the bending moment here?
Bending moment.
Yeah, because you use it here. So can you tell me more about the detail about the bending moments?
Oh, this is
I'm quite curious. Yeah.
okay. Oh, you can see it here. This is the force times the deflection of the ruler.
The force is your extra force.
Yes.
So you use the extra force times the deflection. So can you tell me what's the meaning, the basic meaning here?
Oh, sorry. This is the length of it means the position I press and the stable side.
So I think your unit, I think try to present one kind of force because the force times the So I think maybe you could just some graphics and a ruler when you have something. So which part is N and which part is E. So I think you could draw it out. So I think it is very good equation to solve this. And okay, about the bin theory. So in which conditions that you use the bin theory? So okay, I have this. Because in the bin theory there are two types of bin theory. When you fix here, so the most condition is here in your hand. Because you use a bin theory.
Bin theory.
Bin theory to describe how the big energy is. To measure the Yamashita's and work inertia.
Okay.
Yeah, so in what kind of bin theory that you have used?
Bin.
Yeah, because there are some different kind of bin in the bin theory.
Oh.
Yeah, I'm quite curious about it.
Is that because the difference of the bin
Okay,
theory?
thank you. The opponent summarized the discussion. 1 minute.
Okay, after having a discussion with a reporter, actually about some question about the Yamashita's and moment of inertia, so I can know how the energy transfer and also actually how the energy transfer into a ball. So I try to figure out how the force and the mechanism between the force and energy. And of course, you use a ping pong ball to do experiment, and the reporter then consider the force, but I think maybe the reporter can consider it future because the ping pong ball is very soft, and also the reporter said that with the same length, different length of the ruler, we will have different ejection speed. So I think maybe the reporter could tell more detail about how the different parameters affect the ejection speed. And for the definition of a deflection, the reporter uses a weight to hand on the up end of the ruler, just like a graph one. So, but in the situation, I think he applied the force in the middle part of the ruler. So I think maybe there is some difference in there. So I hope the reporter can tell more detail. And this is all my summary of my discussion.
Okay, thank you. So now the questions of the reviewer to the reporter and opponent.
Question for the reporter. Since you mentioned that the contact area friction is important in the theory, can you please quantify can you quantify the friction of the contact area of the ball?
Friction of the okay.
Can you quantify it?
Quantify. No, I didn't quantify.
Okay, thank you.
Because I
I get
think
your
it
point.
is not important.
Okay, thank you. I get your point. And a question for the opponent. Since you mentioned how does the relevant parameters affect the experiment? If the force applied on the rulers is not uniform, how will it change the projectile's velocity?
I think in different depths of ruler, when you apply the same force, you have different bending situation. So I think it will cause a different energy. So it will cause a different ejections.
So it will vary because of the different bending moments.
Yeah.
Thank you. I get your point. Does the reporter agree with that? Does the reporter agree with that?
Yes.
And question for the reporter. Can you predict how will can the reporter please explain how to quantify the force you acting on the surface of the rulers?
Oh, this is a control variables in my experiment, so I didn't investigate those things.
So this will be a constant force.
Yes.
Thank you. I get the point. Does the opponent agree with that?
I'm not gonna agree with that. I think the extra point is very important point here. So
Yes.
you control the different and your first applied velocity, even is very important.
Thank you. I get your point. Question for the reporter. Will the rate at which force is applied affect the deformation of the ruler and the ejection velocity for the projectile?
Yes.
Yes. Does the opponent agree with that?
Yeah.
And question for the opponent. Will the roughness of the ruler surface change effects on the ejecting speed
Roughness.
on the surface of the rulers, which will result in different friction or coefficient?
Yeah.
Okay. Does the reporter agree with that?
If I use the same ruler, it won't affect.
Can you predict what will happen when we use different roughness of the rulers?
No, because I didn't do the kind of experiment. I used the plastic one to do the whole experiment.
Well, the reviewer would like to know, can you predict what might happen to your experimental data? Predict.
Oh, you say that I use different materials to do
Yes.
the experiment?
What might happen?
Oh, with the high Young's modulus, the ball will have higher horizontal distance.
Okay, thank you. I get your point. And question for the opponent. Will the projectile surface material change the friction with the rulers and affect the ejection speed?
I think the first ping-pong ball will change.
So what if we use the plastic dome cap? Do you think it will change?
I think it will change if not very hard enough because this is not a regular shape
Yes.
of the cap. So I think if you apply at one point, you will start have to deform.
Thank you. Does the reporter agree with that?
No, because I filmed the video to
Thank you. Now preparation of the reviewer, 2 minutes.
Honorable juries and fellow competitors, I'm the reviewer from Team Excel here. Today I'm going to review problem number 7, Lunar Cannon. This is a common statement, and we will mainly focus on how the energy transform process to the relevant parameters. And how does the extra force exerting contributing to the ejecting velocity? Now, let's talk about the review of the report. The reporter has observed the phenomenon of the ejection of the ball, and this is because caused by the extra force impact on the lunar. And the theory the reporter mainly used is the calculation of Young's modulus to describe how does the different bending moments affect the ejection velocity. And about the force duration, this is how the reporter to calculate the contact area times when the exerting force acting on the surface of the lunars. And about the experiment, the reporter has done the force analysis and the force acting position, which is the parameters to the reporter's experiments. And the reporter didn't do the different materials of the lunar. However, she chose a very interesting parameter, which is different length of the lunar. And of course, she has done the calculation on Young's modulus, which is very important as one of the influencing factors, and the variable as mentioned. Now let's talk about the strong and weak points for the reporter. The reporter did a great job for providing a detailed theoretical derivation and provide a clear observation video. However, there is lack of a theory line in some shots and failed to control the force in the experiments. And the reporter did well in explaining how the theory can be used on the experiments and explain the phenomena clearly. However, there is lack of comparative experiments under different conditions to verify the influencing factor, and the chart is not unclear. Now let's talk about the review of opposition. The opponents did a great job on discuss the boundary analysis and provides different analytical perspective and discuss how relevant parameters affect the experiments. However, they didn't discuss the energy conversion of the lunar and didn't notice the lack of error analysis and didn't notice the deviation caused by the experimental setup. However, they still discuss the energy transform process, which is really important to lunar cannon this problem. And this is a case discussion. They made a discussion on the measurements on Young's modulus. The opponent asked, can you please explain how to measure the Young's modulus? The reporter's answer is add mass on the different length of the plastic lunars. The reviewer thinks that the calculation of Young's modulus can be used to describe how different materials of the lunars they affect the phenomena. So we think the reporter can do the further experiments of how different materials of the lunars affect the experiments. And the next discussion is the friction. That's how does the contact area affect the friction. And the reporter answer is energy will be lost. For example, the friction loss or a damping force. However, we think that it's an important factor to describe the initial condition. Since the reporter puts one side of the lunar on the surface, we think the critical condition will be complicated. So we suggest the reporter to do a further quantify to explain the critical condition. And this is our question. Can you quantify the friction of the contact area of the ball? The reporter said no because she thinks it's not important. Next. And the next question is, can you predict how will velocity change if we use different lunars? And the reporter's answer is higher Young's modulus will have higher horizontal distance. And the points means it's about the parameters, which is friction coefficient of the ball. I think this needs to be considered. And about the energy conversion process, we think since the problem statement has mentioned the energy conversion, it's very important to consider. And ignore the effects of iron balls and overlooks the influence of the friction. And method of the experiments need to be quantified.
Thank you. Now is the concluding remark of the reporter.
Hello everyone, I am Ryokan from Variable 2. And this is my concluding remark. First, an opponent asked me that if the different ledge effect, I think that the horizontal initial velocity and the horizontal distance will be affected. And the opponent asked me that did you use hand to exert energy and extra force? I replied that no, I use a clip. And to compare different parameters, no, I didn't do that. Where do I exert the force in the same place? Yes, I push it in the same place, and it is like that of 15 centimeters.
you. Now is the questions of the jury. Please stand up. Any questions from jury? Okay, 林老师。
Actually, I think the reporter is talking about the energy, but I'm much curious about because this is carbon. So the discussion of momentum will be quite few. So I want to ask the opening, like, to review, because the reviewer says that the Young's margin will change the speed of the projection. Right? So how to explain that?
Opponent will answer the question first. Okay. What's your opinion about the role played in momentum in this question?
I think it will affect a different bending situation, which means the different energy of the fluid.
I'm focusing about
Momentum.
Momentum.
Focus on momentum.
I think that because you apply the same force on it and both triggers very fast, so I think the different the momentum
how it
is
related to Young's conjugation.
I think just by the equation on the force, using the energy transfer to describe the
Reporter, do you have any comments on the momentum? Momentum.
Because momentum related to speed.
Yes.
How did the ball get momentum from if we change the Young's model?
This one related to what is
This is the energy. I'm talking about
Yes, because the velocity will change because of the different elastic Young's modulus. Yeah, as I did an investigation about this. So Young's modulus will definitely impact on the velocity.
Reviewer, what?
We think it's based on how you act exerting force on the surface of rulers. Since the projectile's velocity is energy mostly comes from the potential energy, the deformation of the rulers. So we think the way how you exert the force on the surface of rulers is really important. Since when we exert the force on the surface of rulers, it will create a deformation. And this deformation will transform into the kinetic energy of the round projectile. So this is related to the momentum that the jury has mentioned.
Any questions from jury? Okay, I have a general question. The reviewer point out the missing point, friction. Could a reviewer provide more information on what the friction you think is important for this question, and because the reporter is saying is it not important?
Because the problem statement has mentioned that we need to insert the round projectile inside of the rulers. Under this condition, the round projectile will not eject, and it's mainly because of the static friction. So we think the friction coefficient is important related to the critical condition and the initial condition of the ejecting velocity. So the
static friction of the lunar surface.
yes, we think it's a critical condition that the reporters can consider, so can further completely this critical condition.
So, opponent, what do you think about the friction in this question?
I think the friction is just also like a critical condition, because if you didn't consider friction, even you just apply a very small force, it just will drag out. So the applied force with friction trigger, you need to apply more force on it. So I think it's very important to limit the both initial stages too. I also agree with the reviewer.
Thank you, sir. Reporter, what about you think the friction?
Yeah. After the discussion with the reviewer and opponent, I still think that friction is totally variables in my experiment because I talked about the phase that the ball injected out, so the friction won't be the thing I discussed about. And also the phase of the rulers and the ping ball is the same, so it won't vary when I do a lot of different experiments.
Okay, thank you all of you. So that's jury phase grading. Thank you. Please sit down. Okay, now the grade for the reporter. 5, 5, 6, 6, 5. Okay. Next is the grade for the opponent. 6, 7, 7, 7, 6. Wait. No. The third 6, 7, 7. That's a 7. And then 7 and 6. Okay? And the grade for the reviewer, 6, 7, 7, 7, 9. Okay? Thank you. So any comments? Okay, no comment from the jury. So let's take a 10 minutes break. Thank you, everyone.